Linear search. Linear search is the simplest search algorithm you can think of. What happens in linear search? Linear search looks through a data set, one element at a time, starting with the first element till you find the target value. Or maybe if you have completely searched the whole array and still you didn't find the target value, then you will end the search. So this is linear search algorithm. That is, starting from the first element, you will check each element one by one. You will check whether the target value is present or not. If it is present, you will end the algorithm. The search is success. If it is not present, you will go till the end of the array. And still if it is not found, then you would say the element is not present in this array. This is linear search algorithm. So let us just take a example array and understand. If this is an array and your elements in the array are 20, 31, 44, 17, 19, 50. Let us say these are the elements in your array. And you want to search for 19. How will you search for 19 using linear search? You will go to the first element. You will search whether the element there is 19 or not. 19 is your target value. So 20 doesn't match with 19, which means you will go to the next element. What is the next one? At next index you have 31. Does 31 match with 19? No. So you will move to the next index. 44 again doesn't match with 19. So you will again move to the next index. 17, does it match with 19? No. You again move to the next index. And here you have value 19, which matches with your target value, which means target is found. You will end the search by returning the value that is found. So this is linear search. What if you were searching for 33? 33 is not in the array. So you will keep moving from here till the end. After you reach here, you know, even after looking at the last element, it doesn't match with 33. So you are now aware that the element is not present in this array. So you will return -1, indicating the search result is not present in the array. So this is a linear search algorithm. It's a very simple algorithm. What we'll do, we'll go to the pseudocode. We'll understand the pseudocode and then see time and space complexities of this algorithm. So let us start with the pseudocode. We have a function, linear search, and you have array and a target value. So you want to find the target value in the array. You want to see whether it is present or not. If it is present, you will return that index. Or if it is not present, then you will return -1, indicating that the search is unsuccessful. So what should be the algorithm? You want to go through the array from the first index till the last. So how will you write it? You'll write it as, you'll write a for loop for I is equal to 0 to length of array -1. So you have to start from index 0 and you have to go till length of array -1. Why is it length of array -1? Because if you have an array, the first index will be 0. Next index will be 1, 2, 3 and so on. So if your array size is actually 4, this array is of size 4. But the starting index is 0, which means last index is 3. Your size is 4, but your last index is 3. So length of array will be the size of array, which is 4. So you have to iterate from 0 till length -1, which means from 0 to 3. That is why it is 0 to length of array -1. So in the for loop, you will be going from first index, that is the 0th index, to the last index. So in each of the element, what do you want to do? You want to check whether it is the target value. So how will you check it? You'll put an if condition. You'll see if array of I, that is the value in the ith index, if it is equal to target. What is the target? Whatever you are searching for. If it is equal to target, what do you want to do? You want to return the index. You want to return I. I is the index of that element. So you will do this. You will do this check for each element in the array. So you did it for all the elements. Still, if you are not able to find, that means it's not present in the array. Then what will you do? If you come out of this for loop, you will return -1. So -1 indicates search is unsuccessful. If inside the for loop at any point you found the value, you will return the index of that element, return I. If it is coming out of the for loop, that means the element is not present, so you will return -1, indicating an unsuccessful search. So what is the time and space complexity? Time complexity, how do you see for the time complexity? How many times it is going to each element. So this for loop is the only contributing factor for the time complexity. What does this for loop do? It will go through all the n elements exactly once, because it is going from 0 to n-1. So it is going through all the n elements one time, which means time complexity is order of n, because it is going through all the n elements. What is the space complexity? Space complexity is order of 1, that is constant space. So we are using an array here, still it is constant space. Why is it? Because in space complexity, only additional space that is used by the algorithm is considered. Whatever is the input provided array, that is not considered. If you are using any additional space inside the algorithm, only that is considered. So this algorithm is not using any additional space, so it is constant additional space, order of 1.